Fifth one is a simple problem based on optical activity. Probably you remember when we started our discussion on optical activity, I have mentioned about the instrument using polarimeter tube for studying the angle of rotation brought about by either D isomer or L isomer, as the case may be. Now, the equation which we use is this: alpha within square brackets is known as specific rotation. Alpha within square brackets, specific rotation. Alpha is angle of rotation or observed rotation. C is the concentration of the solution, and L is the length of the tube or length of the solution, as the case may be. Of course, I have omitted some points here. If you remember the discussion which we have seen in the last class, temperature is to be mentioned and the wavelength of the light to be mentioned. Of course, since these are not involved in our calculation, I have omitted this. Now let us go through this problem. An alcohol solution is prepared and it is placed in a 20 centimeter tube. 20 centimeter tube, that is, length is given. The specific rotation is also given. Specific rotation is alpha within square brackets. The observed rotation is also given. The observed rotation is minus 11.8 degrees and the specific rotation is minus 59 degrees. So alpha within brackets known, alpha is also known, length of the tube is given. So you are asked to calculate the concentration of the solution. Now let us rearrange this equation. We want a value for concentration. So I take this to the left hand side. So this equation becomes C is equal to alpha divided by alpha within brackets into L, length of the tube. But here you should remember 2 points. One is concentration is usually expressed in so many grams per ml. Concentration is always expressed in the form of so many grams per ml. And the second point is length of the tube or length of the solution, as the case may be, is denoted by decimeter. But in this problem, length is given as 20 centimeter. 10 centimeter is equal to 1 decimeter. 10 centimeter is equal to 1 decimeter. So 20 centimeter will be equivalent to 2 decimeter. So let us try to substitute these values. Observed rotation is minus 11.8 degrees. Specific rotation is minus 59 degrees into length 20 centimeter. You should not substitute 20 here, but you have to convert this into decimeter. 20 centimeter will be 2 decimeter. We can cancel out negative signs. This will be 118. 11.8 by 118, which will be 1 by 10, that is 0.1. 0.1. C is the correct option. Do you follow? Simply you substitute the corresponding values, but please bear in mind that length is always expressed in decimeter, and this 0.1 means so many grams per ml. Concentration is always expressed in so many grams per ml. Do you follow? Now come to question number 6. It is comparatively simple. Two compounds are given. Both of them are cyclohexane derivatives. Dimethyl cyclohexane. This is, if I consider this carbon as 1, 2, 3, 4, 1,4-dimethyl cyclohexane, and this will be 1,3-dimethyl cyclohexane. Of the two compounds, which compound is optically inactive? Optically inactive. Or I can also modify this in this case, in this fashion also, that is, of these two, which will be cis and trans. In that fashion also I can question it. That is, CH3 above the plane, here also CH3 above the plane, and so similar groups lying on the same side, either above or below, that will be cis. This is also the same, cis. But here you notice, already we have seen under the discussion of optical activity, if within a molecule there is a plane of symmetry, or if there is a center of symmetry, then that molecule will not exhibit optical isomerism. Now consider this. You can think of a plane of symmetry here. So this half, if I consider this as the object, and this half will be the image, corresponding image. So there is a plane of symmetry here. If a plane of symmetry is present, that molecule is optically inactive. So 1,4-dimethyl cyclohexane, since there is a plane of symmetry, this will be optically inactive. All right, consider 1,3-dimethyl, this is also cis. And here you can notice, here also there is a plane of symmetry. Here also there is a plane of symmetry. And so this 1,3-dimethyl cyclohexane will also be optically inactive. So both these compounds, of course you can consider them as both cis isomer, but we also notice that since there is a plane of symmetry in both the compounds, both of them will be optically inactive. So optically inactive compound, A is not correct, B is not correct, C, both of them optically inactive. That is the correct answer for this question. So here you should remember this point. Whenever you consider any molecule, it may be non-cyclic or cyclic, if you find either a plane of symmetry or a center of symmetry, that molecule will be optically inactive. These points you should remember whenever you consider which of the molecule will behave as optically active or inactive. So look for presence of either plane of symmetry or center of symmetry. Do you follow?